working the multiple choice questions 1 to 10. Okay, the 2017 past paper, just working the multiple choice questions 1 to 10 for the higher chemistry. Okay, which of the following bonds is the least polar? Okay, so I've pulled, you can see quite a bit of data here. I've pulled the electronegativities page, which is the one I really need, and also a copy of the periodic table just for, I'll show you in a minute. Okay, so carbon. Carbon is my standard one that I'm looking at here. So my carbon is 2.5. So everything else is matching up against the 2.5. And what I want is the least polarity in the bond. So that means I need it to be closest to 2.5. So let's have a look at the other ones. Okay, so iodine is actually over here. I couldn't quite fit it in. So iodine 2.6. Okay, fluorine, if we can find fluorine, is 4. So iodine definitely winning at the moment, closest to. Chlorine is 3. And bromine is 2.8. Okay, so least polar definitely is this one. Okay, but just to see why I brought up the periodic table, there's a pattern here that you should be pretty much just totally aware of. Okay, here is your top electronegativity. Top right hand side, we're ignoring all of your noble gases because obviously they're just not involved in this. Okay, and then it decreases to your lowest down this end. So if you know this pattern, you know that it's decreasing this way, then you can kind of see why you would have your least polar is going to be between these two. Okay, so sometimes just knowing the pattern is enough if you are confident in it. I would say that I would always check the data book, but that pattern you should know. Okay, question 2. Which of the following compounds would be most, and they have highlighted it, so therefore important. So I change my pen back. Okay, what would be the most water soluble? So if we're looking for something that likes to be near water, obviously not using the word like in an exam because these are inanimate. Okay, so our charges are negative on the hydrogen, sorry, negative on the oxygen and positive on the hydrogen. So we have this set up here where we have permanent dipoles. If things are going to be soluble in water, then they're going to want to be near these permanent dipoles. So what I'm looking for is things which have permanent dipoles. Okay, so what I'm looking for are these. There's a hydroxyl. That's going to be a permanent dipole in here. Your carbon to hydrogen ones are not that good. You know, it's like a 2.2 to 2.5, so it's not a very strong dipole. So they're not going to be super happy being near this, okay? But this one has 2 hydroxyl groups on it. This one's got a carbon double bond O, so that is a little bit more polar than your C to H's, but it's going to be way outweighed with an O to H. Okay, so this one is going to want to be more associated with the water, so therefore is going to be the most water soluble. It doesn't necessarily mean it's going to be super soluble, but it is going to be soluble. In fact, sorry, I've not coloured those ones in as well. Okay, so definitely D. Okay, question 3. Which of the following atoms has the greatest attraction for bonding electrons? Now, frankly, this is just another question on electronegativity because this is your definition for electronegativity, really, that it wants to pull the electrons towards it. So what are we looking for? We are looking for sulfur. Sulfur is 2.5. Silicon is 1.9, nitrogen is 3, and hydrogen is 2.2. Okay, so greatest attraction is definitely nitrogen. But yet again, here's your top end of that attraction because fluorine has the least number of shells in the way shielding the positive pull from the nucleus. Okay, and we're going to go down that way, and down that way. Okay, so since nitrogen is here, let me highlight these ones, nitrogen's here, just look at the pattern, silicon is further away from that one, sulfur is down another level, and hydrogen is over here. Hydrogen doesn't totally fit the pattern, but if you think about it, hydrogen doesn't really fit where it should be anyway, which is quite often why they put hydrogen in a box over here. Okay. Question 4, which type of structure is found in phosphorus? Actually, let me just grab this and put this down here so we can have another look at that. Okay, right? The only reason I'm pulling this in is because you're supposed to know some patterns of this one. Okay, so obviously you should know your line for your metal, non-metal. Sorry, no, it's not the neatest, but okay, so here's our metal here this way. So these are all metallic on that side. Okay, here's phosphorus. So let's get rid of metallic. Okay, we should know that this group here is your monatomics. Okay, not that. So we have non-metal, so it's going to be covalent, and then you need to know whether network or molecular. So you should also know that this little triangle here, okay, these are your networks, and everything else is molecular. Okay, you actually should know more precisely that we have a P4 here. Your other new one really is S8. All the rest of them are your diatomics. You know, the I have no bright or clever friends, or however you remember it. Okay, but your hydrogen, nitrogen, fluorine, oxygen, so your little 7 with the dot. Okay, so covalent molecular for that one, and obviously our weird one in here, carbon, can also have covalent molecular, but we tend to go network with that one. Okay, so we have covalent molecular. Question 5. The polarity of molecules can be investigated using a charged rod. Charged rod will attract a stream of polar liquid flowing from a burette. Okay. Which of the following liquids would not be attracted? We have a not in here. So I'm looking for something which does not have nice polarities going on. Okay, so water. Already mentioned that today, so definitely polar. And water would attract water on this one. Okay. Sorry, charged rod would attract that one. So it's definitely not water. Okay. And then we've got propanol and hexane. Let's just draw them out. Okay, propanol, 1, 2, 3, double bond O. Okay, propanol, 2, 3. We are assuming that it is a group. It could be on 2 as well, it doesn't actually matter. And hexane, 1, 2, 3, 4, 5, 6, 7. Stick on your hydrogens here. Okay, I am looking for polarities. Okay, so which one would not be attracted? This one here is completely symmetrical and doesn't, and doesn't have charges on that. Okay, so there we go. Okay, propanol, we've got our OH here, which is going to have charge, and propanone, it's not super huge, but you're going to have a dipole attraction in here. Okay. Okay, equation is balanced when? Okay, let's just draw out the equation. This one's actually not a bad balance, because obviously what I do first is I just work the whole paper. So some of them I'm like, oh, not so nice, and others I'm like, it's okay. Right, so let's start with phosphorus, P2, P4. There's your 2. Okay, that gives me 4 of these. I've now given myself 8 hydrogens, so over here I'm going to change that to 4. So I've now got 8 hydrogens over here. I've now got 10 oxygens here plus 4 here, so I've got 14 oxygens. I've got an O2 here, so here's my 7. So X is 2, Y is 7, and Z is 4. There we go. Okay, what is the systematic name for the compound below? Okay, you just follow your rules. Okay, so rules that you need to follow are: find the longest chain. Okay, and the longest chain has to contain the functional group. Oh, sorry, my writing is very scrappy this morning. Okay, so I need my OH in here, and well, 3 is my longest chain. Okay, right, and then I need to number with my lowest with the functional group. So here's my carbon 1, here's my carbon 2, here's my carbon 3. And then I need to find any extra groups that are attached, so substituent groups, and I've got a methyl group off here and a methyl group off here. So what I have is, where we're going, 2,2, dimethyl, prop, and 1-ol. Okay, so B. Which of the following fatty acids is the most unsaturated? Okay, this one I think is a little bit more work. you have to really understand what you're looking at in a fatty acid. Okay, so, well, let's make our life slightly easier. In fact, let me just draw out what I'm talking about for a basic fatty acid. Okay, fatty acids have to have the acid bit, which is this bit here, okay, and then it has a bit in the middle, which is a repeating section of C2s. Okay, so that could be lots of them, and then it has to be capped at the end with a CH3. Okay, that would be your kind of absolute standard of that. Okay, that CH2, this one can be expanded quite a lot, or not. You know, it doesn't have to be huge, but it needs to be reasonably enough to balance off the acid part. Okay, because we need to have two different ends to this molecule, one that doesn't really like being near water at all, which is the fatty part, and one bit that likes being near water, which is the acid part. Okay, right, so this bit here with the C double bond, or the C, two H's, CH2, this could also have double bonds in here. Okay, and every double bond in this stretch makes it unsaturated. So the more unsaturated it is, the less hydrogens you have relative to the carbons. Okay, if it's fully saturated, then you would expect it to be a CH3 at the end, and then exactly CH2 in the middle. Okay, so let's have a look at all of these ones. So I'm going to totally just ignore all of this C double bond O bond OH, because that's at the end of all of them. Okay, and then to make my life easier, I'm going to take off the CH3, and then I'm just going to look at what I've got left. Okay, so if I've got C15H29, let's just take off the CH3 at the end. That would actually give me C14H26. Okay, so given that, I must have one double bond. Okay, because this should be, if it was totally saturated, C14H28. Okay, but I've actually only got 26. So that means I must have changed something that looked like that. Okay, I've had to rip off these two hydrogens to give myself a double bond space. So that's dropped down. So this one, when they're looking for the most unsaturated, I've got one double bond in here. I have a feeling this one's going to get quite scribbly. Okay, next one, look at B. Okay, so C15H31. Take off that CH3 at the end to make my life a little bit easier. So I've got C14H28. Okay, well that one, that's 14 doubled, so this one, you know, did the calculation down here, this one has no double bonds at all. Okay, right, let's have a look. C17H31. Okay, get rid of that CH3 at the end. So C16H28 again. Okay, so 16, I should have, if I was going to have my normal like CH2 thing, that would give me C16H32. I've not, I'm 28, so actually I've dropped off two sets of hydrogens here. So I've got two double bonds in this one. Okay, and last one, C17H35. Let's drop off the CH3 at the end. So that's C16H, we're going 32, 16 times 2, 32, so that's got nothing. So most unsaturated is C. A lot of work. You can maybe just see the pattern. I would do the work, but it is quite a bit for the mark. Okay, which of the following is not a step in a free radical chain reaction? Okay, you need to know these. Okay, so free radical chains start with an initiation event, and then we have propagation, and then we have termination. It's possible to even skip out the middle one, okay, but you have to start and you have to end, and activation has got nothing to do with it. Okay. And question 10, which of the following is an isomer of ethyl propanoate? Okay, you just got to do the work on this and just make sure you're happy with it. Okay, so what we're starting with is this. Okay, and I'm looking for something with the same molecular formula, but a different structural formula. Definition of an isomer. Okay, so what have I got here? C5H 10, O2. Okay, so I need something with the same as this. So, right, there's one of these I can get rid of straight away actually. So methyl propanoate, meth means that's a 1 carbon, and prop means I've got a 3 carbon, 3 plus 1 I'm hoping we can get is 4, so there's no way that A's in the running at all. And then I've got pentan 2-one, pentanoic acid, and pentan 1,2-diol. Okay, I think the easiest way genuinely is just to draw it out. Okay, so all of these are 5 carbons, so I'm not too bad with this one. In fact, let's just put all the 5 carbons in, and another one here. Okay, right, so pentan 2-one. There we go. Oh, I'm out now because I've only got 2 oxygen. I need 2 oxygens rather, and I've only got 1, so let's just get rid of that. Okay, pentanoic acid. Double bond O, bond OH. Okay, I'm liking my 2 oxygens. Let's check my hydrogens. I've got 1 here already. 2, 3, 4, 5, 6, 7, 8, 9, 10. I like that. But just to check, because you always check, pentan 1,2-diol. Here we go in, so we'll put an OH here and an OH here. Being careful if I'm doing this. Notice that my bond is going to the oxygen, it's not going to the hydrogen. If I draw it like this, in the middle, I could lose the mark. If I draw it like this, where we're going, I definitely lose the mark. So it must go through to the actual oxygen, okay, because that's where the bond actually goes. Okay, and sorry, we're putting this in, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Definitely too many hydrogens, definitely C. Okay, first half of the multiple choice done.